All right, so this is chapter 5. Chapter 5 has to do with functions. Functions are not necessarily just straight lines, but they're different kinds of graphs and what's happening. So this first one this is a graph, and this is called the distance away from a base, and this is actually from the textbook. If you have a textbook at home, it's from page 198, and they're talking about the vertical distance a climber is from the base. So as they're going up a mountain and coming back down, etc. Well, they're not coming back down, but this is as time goes on. Now you'll always notice time is pretty much always on the x-axis. The reason the time is on the x-axis, this is called the independent axis. You can't change time, right? Time can change you as you get older, yeah, but you cannot go back. You can go forward in time, but you can't go backwards in time, right? Okay, so O is the origin. This is the base of the mountain. So they say, this shows the vertical distance of a rock climber as they're from the base of the cliff. So are they climbing, are they resting, or are they descending, and describing what's happening. So from O to A, they're climbing. All right, so you're going up, right? The distance from the base, you're going up a wave. A to B, they're resting. How do I know? Well, because this distance right here, it stays the same for this time period. Then they're climbing again. Climbing. But notice it's not as steep, it's slower. And then C down to D, they're going down, descending. Descending. And then D to E, once again, they're resting. Resting. E to F, climbing. Climbing. Why is there? And then F to G, resting. Resting. So that's what's going. You're going up and then you're resting. You're going up again, come back down a little bit. Maybe you fell, who knows? Then you're resting. And then E to F is a slower climb, way slower. See, it's not as steep. The steeper the line, oh yeah, like the slope, the faster it is. So for B, it says, is there more than one interpretation of the actions for A, B, and C, D? So resting, they could be resting. Well, basically what it is they're stopped. So they are stopped, but maybe they're still moving, but the distance from the base, they're not going up and down. So they could be stopped, or they could be on a flat area, right? So they're not increasing, they're not going up higher, and they're not ascending and not descending. They could be on a flat area. C, it says, is there anything you listed as climbing that you would change faster or slower? Slower. This is probably the fastest. A to B is probably the fastest. Right? Think about the slope. And then this is still going up. This is the slowest. E to F is the slowest climb. And then the last part says, what would happen if you wanted to return back to the base of the cliff? Well, as time goes on, maybe you're going to come back down. This is when you hit back. Now, if you fell off the cliff, you come straight down. But they probably climb slowly, slowly down. When you hit back to the base of the cliff, you're back at the distance away from the cliff. So think of this as the height. If you come back down, you're back at base 0. So back at height of 0. Okay, so that's just somebody climbing up a mountain. Notice these could be straight lines or not always. You never know. It could be a curve. So this one is, okay, let's match these up. The temperature of a cup of hot chocolate over time. If it's hot right now and you leave it, it's probably going to be cooling. So if I'm talking about the temperature, it's either going, that would be increasing. I want it to be decreasing. This is increasing and then decreasing. This is increasing and then staying the same. This is decreasing. And this is always increasing. So temperature of hot chocolate, I would probably say this is A. Okay. What's next? A car is accelerating to a constant speed. So accelerating means it's going up. So going up and then coming back down. No. The car is accelerating and then it has a constant speed. Ooh, if this was speed, yeah, see, this is always the same. It's not going up or down. I would say this one's B. This is just accelerating, going up. And this one is going down. Well, we already used this one. The distance person walks from home, the height of a soccer ball. You know what? I'm going to go for D, the height of a soccer ball, because a soccer ball is affected by gravity. That's what this is. Anything that goes up in the air is going to come back down. I bet you this one is D. Yeah, because this is going up. This is the distance person walks during a hike. Yeah, the distance you walk as time goes on, the distance here is going to be getting bigger and bigger and bigger because you're walking further and further. Now it's a straight line, which means you're probably walking at a constant speed. You're not increasing and decreasing. But as time goes on, the distance increases. So this would be C. Okay, and then let's see. What is the third one? This one talks about, let's not worry about the third one right here. Let's link some of these ideas here. So the steeper the line indicates, well, the faster it is, right? So the steepness of the line really indicates how one is changing for the other. So it indicates a, how do we word this? A faster rate of change. Faster? Yeah. So the steeper the line, the faster you're going. Think about velocity, and a rate of change is like a velocity. So yeah, this could be a velocity, or in other words, a speed. Same idea, right? Velocity is a vector, speed's a scalar. And it may be increasing or decreasing. An increase or a decrease. Now, seeing as we always want to put time on the bottom, you read a graph from the left to the right. So something that's increasing would look like this. Increasing, going up. Because as time goes on, now instead of using X and Y, this could be time and distance, for example. It doesn't have to be X and Y. Quite often we use T for time. This would be increasing. Or if it was decreasing, something that's going down. Decreasing over time, right? Time. So something that's decreasing means it's going down. We always read it from left to right. A horizontal line means that there is no rate of change. There is no change, rate of change. I should say rate of change. Okay, let's do this. No rate of change. So in other words, if you think about like somebody climbing, that means they could have stopped. Or in other words, it's no longer, yeah. So if this is time, as time goes on, right? And if this was, I don't know, like distance or something like that, if it's always the exact same, that means it's not changing, okay? Horizontal line. So in other words, something with a slope of 0. So think of that as the slope is kind of like the speed. A speed of 0 would be a horizontal line. There is no rate of change. And not all relationships are going to be represented by a straight line. Well, we did straight lines in chapter 6, right? We did those first because straight lines are pretty good to figure out the equation. A curve shows that the rate of change, in other words, like the slope, is not constant. What do you mean? So if you have a curve, you could be increasing, like speeding up or slowing down. So on page 201, they've got a they've got a picture of a wakeboarder. It says a wakeboarder is going to be doing this. So they want you to describe what's happening. So this is where you start, and this is the distance away from the start. Okay, hang on, so let's start. As time goes on. Now remember, you can't go back in time. So graphs can never go backwards in time. No. If you could go back in time, I would be back in like last year, and I wouldn't be doing this stuff at home. So what's happening as the wakeboarder, as you're going away? So starting off at the, so from O to A, O is where you're starting from the dock, right? So actually, let's just call it A. So A, you're at the dock, and then they get further away. That's the distance away from the dock, and then they start speeding up. So you started off slow, got your feet, and then you speed it up. So A to B, you're speeding, right? The distance is getting further and further away, and you're going in a straight line, constant. So you're moving away from the dock, right? At a constant speed. Or a constant velocity, if you will. Okay? And then from B to C, the distance hasn't changed, right? So it's the exact same distance. So maybe this is where you wipe out. B to C, wipe out. Okay, so you wiped out, and the distance is, as time goes on, the distance is staying the exact same. And then from C to D, moving away again. See, you're moving further and further away. Moving away. Is it the same slope? It looks to be pretty close. Maybe it's a little bit faster, but it's still straight line, still constant. And then at D, all of a sudden you're not getting further away. Now you're actually, so D turned around and you're moving, now you're moving back towards the dock because the distance is getting smaller, right? And this is really steep. D to E, okay, so now I'm moving towards the dock. And that's pretty steep. Once again, the distance is stopped. Or let's see, the distance is staying the exact same. So maybe this is a wipeout. E to F is going to be another wipeout. Wipe out. Or in other words, you stopped moving. Oh yeah. Now if that makes sense. Or then let's see, what's the last one? F to G, you come back and you're back. The distance is 0, so you're back at dock. F to G, back to dock. This is a straight line. It's at a constant speed. A constant speed. Anything straight line means it's going to be a constant speed. But yeah, so sometimes they'll look like this. That means that the speed's increasing, decreasing, increasing. So they could be curvy. Okay, so let's try another one. It says your turn, so give us a shot here. What's happening? So as time goes on, let's say this is the same thing. You're moving away from the dock, and then this would be a wipeout. Wipeout. And then you're coming back towards the dock, back at dock. And then you're moving away again, and either you're staying the exact same distance, so maybe you're not moving, or you're just, if it was on water, I would say once again, this is another wipeout. And then you're coming back to the dock, but slower, right? Slow return. And now you're back at the dock because this would be the distance away. So that was the distance. Now, hang on. I did that one wrong. Let's redo this. This is not talking about the distance. This is talking about the speed. Oh. If this was the distance, that would make sense. So when you talk about the speed, now we've got different things going on. Okay, well, let's try this. Speed starts at 0, so it means you're stopped. Your speed is increasing. So this is, so for A, the first part is accelerating. Right? Because your speed's getting bigger. You're getting faster, 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 faster. And then what happens here, B? Your speed is the exact same. B, so in other words, you're moving at a constant speed. Constant speed or velocity. And then your speed is going back down until 0. So you're slowing down, you stopped. So C is decelerating. I think it's 2 C's. Decelerating. You're slowing down. D is a stop. And then you're accelerating again. D, accelerating. So you're getting faster because your speed is increasing. What about E? E is also working at a constant speed, and it's the same constant speed. E is the same constant speed as B. Yeah, because it's the exact same height. And then this last part, your speed's getting smaller and smaller until your speed is 0. So you're decelerating, F. You're decelerating, so you're slowing down, until stopped at the end. So how about this one? It says, which graph best describes bacteria growth? Bacteria means growth means they're going to be getting bigger. So if you have bacteria growth, if the bacteria's food supply is limited, so as time goes on, the number of bacteria is growing. Yeah, it's going up, it's going up, it's going up. What's going on here? Here, the bacteria are going down. The number of bacteria is going down. In other words, it's dying off, and then it starts growing. It's not this one, because it's growth. What about this one? Starts off as kind of constant, and then it's growing, and then it kind of flattens out, and then all of a sudden they start dying off. That makes sense. The food supply is limited. They're going to increase for a while, and then when there's too many bacteria, if the food supply is limited, they start starving and they start dying off. That's got to be this one. This one doesn't say anything. No, it is constant growth, but this one's talking about the food supply is limited. So how about this one? It says, which graph represents a person's height as they age? Well, let's see. It's not realistic to start at 0 because nobody starts off with 0 height, but let's say it's going to start. Now this means you're increasing at a constant rate and then you're decreasing. You're not always growing at a constant rate. Some people have growth spurts. I was short for a very, very long time and will continue to be short. But some people grow faster, and then, hang on, what's this? Growing, and then not as fast, and then you plateaued for most of your life, and then they're getting shorter in the end. That actually happens. This shows people that are increasing, and then all of a sudden they start decreasing. I think this one may be a better idea because you're pretty much the same height for most of your life, your adult life, and then you get shorter in the end. Yeah, gravity takes effect. Once you're in your 70s and your 80s and 90s, people actually get shorter and hunchback. Increasing. This one kind of works the same way, but you know what? This one's got the longer flat section because you're the same height for most of your life. I would go with this one, even though they could, because this is growing and then you're shrinking all of a sudden. I like this one that's got the flat section because you're not shrinking until you're later on in life. Age is going to be time, always on the bottom. So I would say it's got to be this graph. Okay. This last one, this is example number 3. This is on page 203. And this one says, Josephine leaves her home. So she's here at her home. She walks to the store. After buying a drink, she slowly jogs to her friend's house, and then she visits with her friend for a while, and then she returns directly home. So using these distances. Well, hang on. The furthest she's going to be away, she's going to go to the store, which is 1 kilometer. Then she goes to her friend's house, which is 3 kilometers. So the furthest she's going to be away is 4 kilometers. So I'm going to do this. Distance is here. 1, 2, 3, 4. Okay, now this is going to be time. Now, I'm not going to do this because it doesn't tell us how long. So I'm not really going to put a scale here, but I do know that as time goes on. Now, what does it say? It says she leaves her home. So she's starting at home. At time 0, she's starting at home. And she walks to the store. Well, she's going to end up walking to the store. So she's walking at some, boom, and then she's 1 kilometer away, she's at the store. Okay? After she buys a drink, so she's going to be at the store for a little bit of time. And then she's going to jog to her friend's house. Now, her friend's house is 4 kilometers away, so she's going to go up to a distance of 4. Now, is it going to be the same slope? No, it's going to be steeper because she's jogging. So this was walking, jogging. I'm going to go steeper. Now she's at her friend's house, okay? 4 kilometers away. This little section of time really is the time she spent in the store. Okay, and then she visits with her friend for a while. Okay, so here we go. We're going to be the same distance away for a while. And then she runs home. She runs directly home. So she runs home. It's going to be going back home, but it's going to be steeper than jogging. So it's got to be not the same. It's got to be steeper than jogging. See? This is one slope. This is a steeper slope. And then she actually gets back home. So she starts at home. She ends at home. Here's where she's at the store. Here's where she's at her friend's house. Now, here's the thing. It doesn't have to be straight lines. It could probably look something curvy. So they might give you a curve that looks like this, right? Because you're going to slow down when you get there. And then you're going to curve. So it could look something like that. Okay, so what are the key ideas that we want to look at? So when we're comparing two quantities, straight lines are used to indicate a constant change. To indicate, hang on, let's do this. Indicate a constant rate of change. So if you see something that's a straight line, think of it as like a constant speed. I'm driving in my car at 50 kilometers an hour, exactly 50. I'm not speeding up and slowing down. That would give it different kind of curves. Okay, so curves are going to be used when it's not constant, when the change is not constant. So think about it, accelerating in your car, this would be going at a constant, this accelerating would look like this, where you're getting faster and faster and faster. It'd be a curve. So horizontal lines are going to be used when there is no change, used when 0 change relative to time. Relative to time. So in other words, if you're stopped, or so, think of it like a velocity, probably when you're stopped. Or with the wakeboarder example, that's where you wiped out. Yeah, you're no longer moving. So yeah, this would be a constant rate of change. Here you're increasing super fast, but then you're kind of slowing down, right? So this would be non-constant. So maybe this is decelerating. Accelerating would probably look like the other one. So non-constant. And this would be no rate of change. No rate of change. So I'm just going to ask you guys to take a look at a few questions on page 204. They're kind of weird. They're hard to put into words, but we're just going to try and read the graphs. Always read it from left to right and figure out, is it increasing or is it decreasing? Yeah, increasing things look like this, decreasing. Is it constant or is it non-constant? Or is there no change? Alrighty, good luck with these.